Hi there, and welcome to the 62nd and actually last installment of the ChessTDD series. In the blog post that accompanies this, explain my rationale for making this the last post in more detail. Suffice it to say that this is fairly laborious what's going on here, so it would make sense not to continue doing things this way, not to have it take an hour to account for all the different moves in each frame of a chess game, which would imply a degree of automation that should happen here that I'm not going to do outside of the product that I'd eventually like to turn this into. So this led me to the conclusion that after a taste of after giving you a taste of kind of, what QA or field testing on this might look like, this would be a logical place to call it a wrap. So I plan to do just that. It has been a lot of fun. As you can see here, I'm just kind of going through the feature set that already existed for white for black, so there's nothing overly remarkable happening here. So anyway, I was saying it's been a lot of fun, but getting to a point in this series where I need to undertake some serious additional automation to do more testing, or I'd want to start refactoring the application and expanding features, or it's going to get pretty boring. I mean, as you can see, I'm talking over something that's not especially interesting to watch. So the last thing I'd want to do is do a bunch of this for another 20 episodes and, have that serve nobody. So I think this is a good place to wrap once I get all the logic in place for the black pieces here in this actual game scenario. So with that in mind, what I started to do is add these additional methods here to round out what's already in the normal board scenarios, which is a pretty minimal class. Now, adding this here, I started to get a little bit jumpy. I noticed two things. Number one, the squiggly underbuild board from table, indicating that could be a static method. And number two, that I had not updated the name appropriately in that method you just saw me change. But what I shouldn't be doing, and I certainly shouldn't be demonstrating, is refactoring when the tests are read. So what I figured I'd demonstrate here, and I've probably done this here and there throughout these series, is I don't want to forget what I wanted to do, so I'm going to make a note here using Trello. But I don't want to do that refactoring. Even something simple like a rename where nothing should go wrong, I don't want to do that when I'm red, because it's been my experience that doing a refactoring when you're red, when nothing, quote, should go wrong, is a great way to have things go wrong. And then it gets really confusing. So I got my test to green, and then undertook these refactorings. And one thing that's worth noting here is that I got the tests all to go green. That's not to say that I had anything in this test. It was a fairly meaningful one, this new one that I'm creating, but I was green, which means that if in changing the name of the method and in changing that method to static, I somehow broke something, I would see it. And that's really the purpose. It's not to get to where your current test is passing. It's to get to the point where you can process the feedback that something's going wrong. If you're refactoring when things are red, it gets really hard to figure out if you're making anything more wrong, so to speak. So that's really kind of the point. Back to the present, what I was starting to do here was contemplate what I might want this, what I might want, let's see, let me start over in describing this. What I noticed was that I was going to be typing a lot of the same stuff for the black pieces that I did for the white pieces. So I'm kind of looking at that method and thinking, while I'm still green, what can I pull out that would make me have to do less typing in the new method? And so the first thing I thought was, I should also mention that I've been in various places talking a decent bit about using the new C#6 language features, or newish features, to make your code more compact. So I already had that in my head, and I thought, well, I can go in here and define this non-knight coordinates somewhere and then reuse it. And then I also started to look and say, well, okay, all that's really going to vary here in this moves count thing between black and white is which row I'm in. So row 1 versus row 8. And I started to think about, okay, what might this look like if it were a method? Like I could pass in the set of x coordinates that interested me as well as the row, and then have it return a count of moves total from that. So before I got to doing that, I thought, well, why don't I type this out and kind of see what it feels like and get an actual test going green here. And that's something I do from time to time, is let me actually like live the duplication for a second. And maybe that'll help me wrap my brain around how best to factor it. Because I know it's not hard, given, you know, the amount of experience I have doing stuff like this, it's not hard to look at that and see what I could extract. It's more about pulling out a meaningful abstraction that's going to clarify rather than confuse. So I'm not thinking, how could I extract a method from here? I know how that could be done, but would it be a good abstraction? Would it be clarifying? What you're noticing here is NCrunch got something at the intersection between NCrunch and SpecFlow. Some got a little out of whack, so just reloading the tool to get my tests to be green or to be whatever color they should be. I don't like that non-coverage there. So there we go. Now we're back to expected, and I want to make sure I've got my unit testing early detection thing going on here. So now with everything green, I can feel free to continue my mission to refactor this class a bit. So there's a new C# language feature where it's a more functional style that I kind of favor with those declarative lambdas. And what I'm going to do here is, while I'm at it, I think a lot of these could be made more terse in a way that's clarifying. So get context from, or get from context. Instead of having all the ceremony of this method, I'm just going to do it this way, which I think, at least personally, it suits my taste better. I'm going to do the same thing here, and I think it also works for board moves as well. And then I looked to also do it with that get coordinates from table at the bottom, but I think I'd be pushing it there. That's a fairly involved method that I think I will just leave as a method. Oh, excuse me, forgot to set my phone on silent there. Okay, so having done a little bit of yak shaving in that capacity, it's time to move on just a bit here, and let's see. Start to think about the context that I mentioned earlier, and or I should say the proper level of abstraction. So what can I pull out that makes sense? And that's where I sat contemplating this for a few minutes. Well, that's an exaggeration. A handful of seconds. And I figured, well, I can do some kind of get moves from. So I'll pass in the collection of x coordinates and then the row. And I don't know that that's the greatest abstraction in the world, but it's certainly repeated a few times here, and it's going to make these, it's going to eliminate the duplication from these test methods. So I'm going to pass in this enumerable of integers, and I'm going to get away from that name about rows here in a moment, but I'm going to pass in the collection of x coordinates and then the row itself, and encapsulate the concept of going and getting all the moves from the coordinates described by those parameters. Oh, I see. I actually got rid of the method altogether and started over. Okay, so let's, get the x coordinates, and then let's also look at the row here. And from that, get a count of the moves described by this collection of coordinates. And that's what we're really going to be interested in the number of moves, not only for what the non-knight pieces should be able to do, but also for the pawns. So this is going to be applicable in 4 different acceptance test methods, one of which has yet to be written. And I kind of actually do like to do that if there's going to be, some number of them written. Maybe halfway through I figure out the abstraction and then see how well it goes for the remainder, so I can realize the benefits of extracting a common method. All right, so I've defined this static getMoves method, and now what I want to do, since I'm still green, is go and test out using it in all the places where I think it would be applicable so far. I could have done this as an extract method, but that's not always the easiest way for me to think things through. So what I'm going to do is go and test out actually using this abstraction that I've created. So first, I want to try it on the more obvious candidate, at least to me, which was this one I specifically wrote it for, the non-knight pieces. So I'm going to pass in the coordinates, the non-knight coordinates, and then I'm going to pass in row 1, and hey, everything stays green. That's great. So I feel like I should be able to go do the same thing, and I start to copy and paste, but then stop. Feel like I should be able to do the same thing here for the non-knight coordinates, and then just use row 8 instead, get rid of the count and everything. And now this is going to be a lot more compact, and I feel it's fairly readable. So moves count is get total moves for the non-knight coordinates and row 8. It may not be the most discoverable thing of all time, but it's decent. I think you can look at the test method and not be the test method name and not be confused about what's happening. So let's make sure now, if we do the range from 1 to 8, let's make sure that this works also for the all-white pawns, which it does. I will say, in retrospect, one of the things I could have done to create a consistent abstraction is to take range 1-8 and put it up there with all non-knight pieces to say something like all pieces, and then I'd be dealing with a consistent abstraction. I'm a big fan of putting some extra thought into doing stuff like that and making sure that you get consistent and crisp abstractions. I didn't do it in this case because I only just thought of it. So it wasn't that I thought of it and said, never mind. It's that upon review, it made sense to me. Usually, even if I'm kind of in the flow, I like to stop and get those things right in the moment, because I'm a believer in that being a good thing to do. So what I'm doing here, now that I've created this nice abstraction, is I'm going to actually use it in the new acceptance test situation that I've just created, which is to say that all the black pawns should have 2 moves, not no moves, as I accidentally typed there. So I need to get this right in the string binding, and I'm going to rename the method as well. And I'm green because I'm not asserting anything. Now what I'm expecting here is, in this case, I'm going to assert 16 as the moves count, and I expect that to go green. And it does, and that's it. So now I'm testing all of the pieces on the very first move of the board, which is what I set out to do. So I'm going to walk through an actual game, and I'm going to put this go into the product because of the effort involved. And that's going to be a wrap for the series. For those of you that have stuck with me throughout, or for those of you that have come on late, or whatever the case may be, I appreciate all the time that you have invested in watching the series and sticking with it. It's been a lot of fun to do. I've learned things along the way. I've gotten some great feedback from people. And I don't consider this to be the end of it. It's just that I'm going to pivot and do it in a more formalized way from here on out. So hopefully you'll stay tuned for that. I will announce it, and I'll see you going forward. Thanks so much for watching.